Welcome to the PrepNet, presented every Sunday at 6 p.m. Eastern Time on Talk2Me's Channel 14. Come join us to discuss everything about prepping and hear what others have done. All about communications, communications modes, Part 4. Last week, we started discussing digital text communication modes and covered radio teletype, PSK31, Olivia, and JS8 call. We will finish up that topic now. There are too many digital modes for us to cover here, but some of these may have capabilities that might fit your eComm needs. These digital text modes show how computers can greatly improve communication under difficult conditions. If you will be using any of these digital text modes, be sure to include powering and recharging the computer used to generate these signals. However, there is one more mode that predates all of these and is still extremely effective today. Continuous wave, commonly called CW, is one of the oldest radio communication methods still in use today. CW uses Morse code, which represents letters and numbers as a series of short and long signals, often referred to as dots and dashes. Unlike voice or digital modes, CW does not transmit audio in the same way. Instead, the transmitter is simply turned on and off to create a carrier signal that can be heard as a tone at the receiving station. Here is a short CW message. In case you didn't copy it, the message was, "Welcome to Red Bear's PrepNet." The operator controls this on-off pattern using a key, paddle, or electronic keyer to form Morse code characters. Strengths of CW. One of the greatest advantages of CW is its ability to work with extremely weak signals. Because CW signals are very narrowband, often less than 500 Hz, they can be detected even when they are barely above the noise level. This example shows that the CW can still be copied even though there is a lot of noise on the band. CW also requires relatively simple equipment and can be used effectively with low power. Another advantage is reliability. CW can often get through when voice and many digital modes cannot. Because of these strengths, CW is widely used for long-distance communication, emergency communication, and low-power operation. Limitations of CW. The major limitation of CW is that it requires the operator to learn Morse code. This takes time and practice, although many operators find it to be a valuable and enjoyable skill. CW communication is also generally slower than voice communication, especially for inexperienced operators. Despite these limitations, CW remains popular because of its effectiveness and simplicity. Practical application scenarios. Before we close, let's apply what we have learned with 5 practical scenarios. Consider what mode you might choose in each situation. Scenario 1. You want to talk to someone across town using a handheld radio with a nearby repeater available. FM would be a good choice because it provides clear audio and works well for local, line-of-sight communication using repeaters. Scenario 2. You want to communicate with another operator several states away using HF radio. Single sideband would be the preferred mode because it is efficient and works well with long-distance skip propagation. Scenario 3. You are operating in very weak signal conditions where voice communication is difficult to understand. A digital mode like Olivia or JS8 call would be a good choice because they are designed to work in weak or noisy conditions. Scenario 4. You need to send a short, accurate message when signals are extremely weak and unreliable. Continuous wave, or CW, would be an excellent choice because it can often be received even when other modes fail. And Scenario 5. You need wide area communication, but only have access to cellular coverage, not traditional radio infrastructure. A push-to-talk over cellular radio would be a practical solution as long as cellular service is available. These few examples show that choosing the right mode depends on distance, signal conditions, equipment, and the type of communication needed. We couldn't wrap this topic up without mentioning another emerging digital communication mode called Meshtastic. Meshtastic uses small, low-power radios operating around 915 MHz in the United States to create a mesh network. Instead of communicating directly from one radio to another, each device in the network can automatically relay text messages for other devices. This creates a decentralized system where messages can hop from one node to another until they reach their destination, up to 7 hops. Meshtastic devices are often paired with smartphones using Bluetooth. The phone provides the user interface, allowing you to send and receive text messages, view maps, and manage contacts. The strengths of Meshtastic. Meshtastic does not require internet or cellular infrastructure to operate. It can automatically route messages through multiple nodes, extending the communication range beyond a single radio link. It is well suited for off-grid communication, hiking groups, emergency preparedness, and local community networks. The radios are typically inexpensive, low power, and can run for long periods on battery or solar power. Limitations of Meshtastic. Meshtastic is limited to relatively low data rates and is primarily used for short text messages. The range between individual nodes is still limited by terrain and antenna height. Performance depends on having enough nodes in the area to form an effective mesh network. Because it operates in unlicensed bands, it may be subject to interference from other devices. Meshtastic represents a different approach to communication, combining radio technology with networking concepts to create flexible, decentralized communication systems. Maybe with all this talk about the digital modes, it might encourage you to get your amateur radio license to take advantage of these communication modes, as all of these digital text modes are only available on the ham bands. We have covered a wide range of communication modes used in radio. We started with AM, one of the earliest voice modes, which is simple but not very efficient. We then looked at FM, which provides clear audio and is widely used for local communications. Next was single sideband, which is highly efficient and allows long-distance communication on the HF bands. We discussed digital voice, which converts speech into digital data and allows for clear audio and advanced features, as well as push-to-talk over cellular systems that use network infrastructure instead of direct radio signals. We then moved into digital text modes such as RTTY, PSK31, Olivia, and JS8 call, which allow reliable communication in weak or noisy conditions. We covered continuous wave, or CW, which remains one of the most effective modes for weak signal communication. And finally, we touched on the Meshtastic node radio network. Each of these modes has its own strengths and limitations. There is no single best mode. The right choice depends on your equipment, operating conditions, and what you're trying to accomplish. This is why your eComm PACE plan should include a combination of these different modes to cover your different needs and to provide failure backup. As a radio operator, learning when and how to use these different modes gives you more flexibility and increases your ability to communicate effectively under a wide range of conditions. There are many links in the video description pointing you to more information on FLDigi, JS8 call, Morse code, and Meshtastic, so check it out. Next week, we'll start a new topic and talk about water. How to store it. Where can I get it? Purifying it. If you have any questions about what we have discussed here or anything about prepping, send your question to prepnetch14@gmail.com and enter question in the subject line.